Here's a situation I want to show you that's related to the engine cooling system. Now that we have installed a new aluminum radiator, which is 1 inch in thickness compared to the factory OEM, which is approximately a ½ inch. What I want to show you in this video is this leak that's occurring at this water pump, the thermostat housing outlet. This hose right here, this takes a 90 and it goes up into the lower intake plenum. Well, that hose, as you can see, is held firm and sealed in position by a torsion clamp. That will be a clamp like this. Now this two part here, which needs to get clamped, is facing the rear, and this is what's going to be difficult removing. During the process of doing so, you're most likely going to damage that hose, since the vehicle is going to be over 100,000 miles. So as you can see below that hose, you can see that green coolant just seeping down, and on your engine you will most likely have a clutch fan here, which will force air and most likely blow that coolant to the rear, and you might never get to see it in the front. But this is something you're going to have to look out for, because if you've never eliminated the coolant bypass for the throttle body, this is when the engine is going to start to overheat because of that leak. Air bubble is going to develop into the coolant system up here, and this is going to cause the engine to overheat. Now another thing you have to pay attention to is also these steel outlets for the thermostat housing and for this hose connection support will most likely become corroded, and it could be repaired. We have that in another video. I'll probably include it in this video here. But it's very important on this engine that the cooling system is absolutely sealed and you're having no leaks. So this leak will most likely intermittently occur when the engine is hot. Since pressure is applied to that joint, it will have the tendency to just seep the coolant out. Now that it's cold, you can see the coolant is still seeping on that thermostat housing because it's saturated, it's wet. So this is where we have to go and remove this distributor, upper intake plenum, just to get to this clamp facing the rear of the outlet spout. Now this will need to get done with a needle nose pliers. You can see one of the claw on the torsion clamp, and the other one is not going to be easy to gain, so you're going to have to get it from up in here. So this is what I want you to know, is that you have to look out for cooling system leak. It'll be better off for you to go to AutoZone or a parts store, maybe Pep Boys, and get a radiator pressure tester. You open the cap, you put the tool on, read the description on the package, it'll tell you what to do, and you look for leaks on the engine, because after 150,000 miles, 200,000 miles, this engine is going to start to give you problem, and you need the information necessary to repair and render those problems so you could continue driving for 500,000 miles. Connection of the cooling system hose is going to be a little difficult, but what you need to know is on this engine, the VG33E, and maybe others, you're going to have a lot of problem in this area with the coolant circuit. What's going to happen here is most likely you're going to get corrosion that builds up on the thermostat housing, since it's steel, and this will happen if the coolant system is not serviced. The coolant system, the coolant itself, will become corrosive and will start eating away at the metal. Also inside here on the thermostat housing, it will eat away at the aluminum casting, and you will most likely get a leak, and this will contribute to overheating. So you have to look out for that. Like what you see here, this is the pipe, obviously, that connects from the thermostat housing to the lower radiator hose. And in the rear, we can see we have two holes that's due to corrosion caused this hose. So you could get this weld, heat weld, and seal, and then you could paint it with a paint that's not going to be removed when that coolant gets hot, because it's going to end up in the radiator. But most of the time you don't really want to paint this. You just want to fix these holes and order one of these new pipes from the dealer and replace it, because you're going to be spending a lot of time fixing this, every time the coolant system starts to leak from this pipe. And most of the time you get corrosion build up in this area between the hose, and that is where your leak is going to come from. So this is going to require to get sand like you see over here. Then we could apply this adhesive here in this area once it's shiny like over here, and that will give us a temporary fix so we can use the vehicle until one of this is ordered. Let's get a look at the thermostat housing where the hose is connected. When you look at the outside, you're going to see flakes of rust around the housing. This flake has to get removed so the hose could perfectly seat and seal when it's tightened against this housing. Now when we take a look at the inside, it's not that bad on the inside as it is on the outside. But what's important here is most of the time you want to replace this part with a factory OEM Nissan dealer part. Most case, this is what you want to be looking at when you finally is finished with the metal. And this is the repair that was done using this product. It has a 500 degrees Fahrenheit, so this is good for engine temperature, and it's going to give us a temporary seal maybe for like a year until we could locate the part, like I said, for installing. Also, notice the thermostat housing is also going to need cleaning up, preferably replaced. This is what's going to happen to a lot of the joints and tubing, metal tubing on the engine. Like for example, down in this area here, you're going to find a lot of leaks between the intake manifold and the cylinder head. You're also going to get a leak on this hose down here. See this hose here? You see right now it's indicating that it has a leak. So that goes from the thermostat housing to the lower intake plenum. And most of the time you have to replace this torsion clamp with a worm clamp. And you also need to clean that spout like we have done here. This is what's going to happen, like I said, to most of the parts, especially down in the back there where the heater core is. That corrosion and coolant will most likely deteriorate the plastic and damage it. Also, another thing you have to look out for is the throttle body. You have coolant that comes up to the throttle body for warming the body during cold startup. Once that coolant becomes corrosive, it could cause the metal to eat away inside the throttle body, and that coolant will end up inside the engine, permanently damaging the engine and requiring a rebuild. So these are all things you're going to have to look at once you see your coolant system start displaying or expressing or showing corrosion like this. Signs are that it's happening other places inside of the engine. This is when you're also going to want to consider head gasket condition, because this corrosion is taking place on the head gasket, and that later on could get worse if you continue to have water or any other form of coolant inside the cooling system that will negate and negatively affect the cooling system. So what you want to have in here is antifreeze. And antifreeze is a form of coolant. So is water, and so is diesel coolant. But you need antifreeze in here because antifreeze has the solution to prevent this corrosion from happening. And like I says, if the antifreeze become old, it will become corrosive, and that's something you can prevent from damaging the metal inside of the engine. So fixing this part is going to requiring painting, and that's waterproofing it and making it look good. In the event it should corrode in the future, which it most likely will, the color that it's going to be easily displayed or easy to see that corrosion and identify a leak. Finally, the thermostat water outlet pipe has been waterproof, sealed, and fixed. So you can still see where those fixes are. And remember, it's temporary. Let's get ready and install this. It's time to install the air condition condenser and this radiator, which is a new aluminum radiator. Wanted to really get rid of that plastic radiator, really inferior. So we didn't have any issue with clearance down here by the steering box between the fan and the radiator, even though the radiator is 1 inch in thickness and the factory radiator is only a half of inch. What's clever in this installation with the air condition condenser and the radiator is you want to keep them together for airflow, so when the air is flowing, it flows through the air condition condenser and continues on to the radiator. You don't want to have it pulling any air from the sides of the radiator and the air condition condenser, because this is going to create a disruption in flow. So if you take a look in there, you can see what has been done. And a barrier with this plastic here, this foam, it's plastic foam, has been placed all along the side and the bottom and the other side. So when we look at this side here, you can see this is the foam and it goes all the way to the bottom. Now along the bottom here is also sealed for the radiator, and this is for the condenser. When we take a look at this side, you can see we have the foam here all the way going down to the bottom. So this encloses the square of the radiator with the air condition condenser to create a uniform flow, one flow through the condenser and through the radiator as the electric fan starts to operate. This is the best way for cooling the condenser and the radiator. You do not want to have air, like I said, coming from the side, because what will happen is you're going to have hot air circulating through the radiator, and it defeats the purpose, because the radiator is not going to be able to maintain to cool the coolant. So you want to have fresh, cool air from outside of the vehicle going through the radiator and then exhaust itself to the rear. Very important part is when installing the air condition condenser, you have to pay attention to this part where the manifold is installed with the sheet metal. It will most likely have a contact, so you're gonna have to be careful with here. When you take a look at this side, you can see this is what I'm talking about. This is where the high pressure line goes in and the low pressure line is. It's right here. Complete the radiator and air condition condenser installation. You can see the top between the condenser and the radiator was sealed off with that foam. This is enabled to incorporate all the air, like I said, to go through in one direction for better cooling. Not only does this modification benefit the engine and the radiator cooling system, it also benefits the electric fan. What I mean by that is the electric fan is controlled by a coolant temperature sensor, something like this, located in the engine block, and that temperature sensor is monitoring the coolant temperature and is controlled by a module. This module is located right here, and it's adjustable. At approximately 180 degrees Fahrenheit, the module will command the fan to turn on. The reason all this work was done and all the duct work was done to the radiator is to reduce the operation time of the fan and increase its durability. Reason being is when the vehicle is driving, the ductwork will be able to tunnel that air through the radiator fin, cooling the coolant, not requiring the electric fan to operate for cooling the radiator. Most likely, the fan will require operation when the vehicle is standing still, since air will not be flowing naturally through the radiator. As the vehicle begins to drive, that air will begin to start flowing and performing the same action and work as the fan would for cooling the system. That's the benefit of performing the ductwork and enclosing the radiator with its condenser and the opening to the front of the vehicle.